here and ready to tackle Advent of Code Day 6. Unfortunately, I messed up on the timings yesterday and ended up starting yesterday's an hour later, hence no stream, but just a recording only of it. Wasn't too bad though. The actual problem, pretty fun. Ordering, sorting, pretty neat one. But today we're here for December 6th, so got my code ready, got Quokka running, blank TL draw at the ready, and we are off to the races. It's a map. Okay. It's a nice looking map. We have movements in the map. Okay, 41 distinct positions on the map. How many distinct blah, 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 blah. Okay, protect the route. So we have a map, have a location. They move, they hit, they move, they hit, they move, they hit. So they just keep moving. When they leave the area, it's how many places they physically visit. Okay, we got this. We can do this. Let's get the world, which is data split, new line. Don't even need to map those. Our array of strings will do suffice. We need to get our current location. So for let r equals 0, r less than world.length plus, go through all the rows, go through all the columns. Yeah, come on. And then we need to be like, hey, nope, not there. Here. What have I done wrong here? Oh, not C, it's supposed to be R. If world RC equals, is it always going to be this one? Let me get my puzzle input. Yes, it's always going to be upward facing. Love it. I'm going to grab that, shove that in here since I'm here. Drop those, paste those, save those. And then it is let lock equals R0, C0. Then once we find you, it is going to be lock equals RC. There we go. We did it. We found you. I'm not going to add some extra stuff. There we go. Okay, I added the extra stuff. Boops. There we go. Okay, we have it. So now what we're going to do is while lock R less than or equal to, basically while you're on the page, greater than or equal to 0, and lock dot R less than world dot length, and lock dot C greater than or equal to 0, and lock C less than world 0 dot length. Basically, as long as you're in the world, you're gonna keep moving, little buddy. And the direction you're moving is, let's put a break statement there. Do not eat my computer alive. So the direction is going to be based on this. So const to direction. And then if car equals this, return -1, 0. And yeah, let's just write for the rest of them. So what are the 4 options we have? Up, right, left, down. So let me see, right, which is there, which means no row change, 1 column change. V, which is positive row change. And then left, oops, which is that one. Yeah, we have that handled. basically going to keep moving until we hit a thing or we have something in the way. So, let me see. Let visited. We should keep an array of visited locations. Visited push current location, and then let's see const and R and C. Well, const ROCO equals car to direction, which I don't really need the character for this, but let's go ahead and include that just for goodness sake. And then what determines our spinning, right? 90 degrees to the right. Okay, that's relatively good. Equals R plus RO, C plus CO. Well, location R. Location dot. Now we have to detect if new and front equals world R and C optional chaining there. If in front equals a hash, then 2. Right? Otherwise, we are moving forward. Location R equals in R. Location C equals in C. So let's put an else there, really. There we go, so we have the else. Then it's rotate by 90 degrees. Cars, I'll just put this here, 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 here. Those are all 4 directions. So it'll be +1 module around it. So location dot. Yeah, hold on. Moves up several lines, loads some obstacles. Turns right, continues straight in a new direction. Right. So I think I just do logic inline to here. Keep us moving forward in a direction. Location car equals index of +1. So chars. Yeah, chars index of location char +1 modulo chars dot length. So we do that, and then chars the new one like so. That's not actually gonna get us anywhere. So we're just gonna be like, hey, you just took a 90 degree to the right. But next time, you'll do better. You're going to go forward in a different direction. So it's going to be 2 visited on the same slot, which is perfectly fine. We'll eventually make it, and then we will return visited.length. And let's see if this eats my computer. It looks like we are a looping. No? Okay, we're instantly terminating. Interesting. Where is our location? Well, greater than 0 and less than that and greater than 0 and then did that. Okay, so we instantly terminated. Why? Location, character updated, location. Yeah, this is all supposed to be good. Sure, so let's look at in front. Well, location, I suppose. Wait, 0, 0, what are you doing there? Oh, okay, we're also missing this. Row call. I messed up on the world then. It's in there. 0, 1, 2, 3, 4, 5. World row column. If it equals the thing. Just a single row. What have I done here? I've done something wrong. Okay, so this is the same row. Hello? What's going on? You've just failed to write a basic for loop. This is amazing. I love this. Oh, it sets if the thing, blah, blah. Oh, yeah, we don't want that. There we go. Okay, now we finally hit it. Now we did it, and we just have too many. So these are the duplicates I was speaking about. Let's just say, we just want to get rid of them, basically. I think we can just say new set visited that map B, and then we'll just say R beta R C beta C this that size. Still gonna give us too many. That's because we've only gotten rid of the character, which is good. I'm mapping further to a JSON stringify the put the map in the wrong place, so that would help. Fly. And that, and we have it, and it's a number. Shake the number, and we win. Boom. Ooh, stuck in a loop, huh? That's sad. The heck is going on here? How many positions can you choose for the new obstruction? Okay. So we add one new obstruction. Give me my new example input, please. A new obstruction that the guard will get stuck in a loop. Okay. All possible positions for an obstruction that can start a loop. Okay, in the above example, there are only 6 positions where a new obstruction will cause a loop. Interesting. Okay. Let's get this 6 down here. Get my new input, or my old input, I suppose. Hmm. Okay, so without the guard noticing, seems to be a rule of placement here. Let me figure out what that means. Cannot be placed the guard starting position. Okay, so it's placeable anywhere. That's not where the guard currently is. Interesting. So what I'm looking to do is there are a bunch of places it goes, and eventually it creates a square with these. So the corners of where it turns makes a square. Just naturally. And to detect where those squares are made, and then based on the velocity of the incoming thing, be like, hey, wherever that square is made, opposite velocity plus 1 is where I can put an obstacle. Alright, so let me get this on the next line, but get dot trimmable so I can visually follow this. Yeah, we go up here, we go to the right, go down. What are they drawing? Oh yeah, right. Then we go left. Okay, so we're detecting these squares. Now what I have is just an array of positions that I've hit. Would it be useful? So I don't have one, and I shouldn't guarantee that I have one for this third. Interesting. Okay, let me look at the other examples. Another square. Again, I have more corners I hit. square. What's this one? Wait a minute, what is this one? Oh wait, what am I looking at? This last one here. Go up, right, down, left, up, right, down, left. Oh, okay, yeah, there was another square that is part. Okay, I see. A sub-square. Ooh, that's not a square. That just creates an infinite loop. Interesting. So my square detection completely fails at this one. There's no square to be made. Okay, interesting. I'm not really sure. I'm not really recognizing the pattern of this particular one, unfortunately. What I can do is a very ugly and sad thing of everywhere I go, try to put an obstacle in front of my face. Simulate and see if I hit a loop, which is being at the same place with the same character. It's going to be very painful because the input's that large, but it will work because I will try every single place. Let's go for that. Right? This is my brute force, so I'm going to go for it. Do-do-do. Brute force away time. Okay, so we have all our places. We got to make sure we end up in the thing or we hit an infinite loop. An infinite loop is we have been at the exact same of this before. So it's basically before we go here, we check, hey, have I seen this location before? So if visited, find index or has or includes or find index would suffice. Old location equals basically not equal -1, right? Break. Ah, forgot to put JSON stringify on the other side. There we go. Now, this is technically sufficient. We need to break this into a little bit more modularity. Just break it into tiny function. That's a horrible function name. World. Let's see, visited, return this. Location or number to string. I guess you have a world. There we go, and then we get to return some stuff. Is return loop. Otherwise, okay, let's see. What we name this thing? We give it a really cool name. Ends in loop. If so, return true. Otherwise, return false. Very expensive, but it'll work. Could definitely use some fast forwarding here. So now the world ends in loop. So we find all of our possible positions to put a thing. We do it. We see if it ends in the loop. Now what we need to do is actually try to put obstacles. So const positions equals right here. Yeah, we don't have any loop section here. We're going a normal thing. So the thing is, every time we move, we try and consider, hey, let's put an obstacle in front of my face. So we always consider right here as an obstacleable position. If it's not undefined, of course. I believe. Yeah, let's try that. If in front not equal, well, basically if front is a dot, and obs positions push R and R, C and C. Otherwise, just keep moving your life forward. I like that. Let's look at, see which ones we got up. Yeah, 43. That's honestly not too bad. Is what I was anticipating. And it doesn't go off the world. I can see there. 5, 4, 4, 4, 3, 4, 2. Right. And it doesn't consider ones that are already in the universe. Because that would consider 0. Yeah, it doesn't hit row 0. Okay, good. I like it. Then it appears. It looks like we're doing the 90 degree, so we're seeing both of them. Okay, so we have this. We just need to try every one and see if it ends up in a loop. So for position, obs position, we need to put that in the world and take it back out of the world. So this does need to be mutable. Every time I don't do it, I ended up needing to do it. It's hilarious. So we have that. So what we're going to do is kind of like a backtracking Sudoku solver. I guess we'll make this RC equals a hashtag, then world C equals back to being a dot. After we do our thing, we do need to save our location. I guess we'll just do a thing of start lock. There we go, just to save that, because we need that. And then let's see, count equals 0. And then let's call our Coolio function. World ends in loop. Starting location. You're mutating this, aren't you? Yes, you are. Then the world, if loop return loop count. 7's not equal to 6. Oh no, it's an off by 1. Let's go with it. Ooh, and now it's eating my computer alive. Yikes. Big yikes. Yikes, yikes, yikes. Yeah, it's eating it, so we're going to stop clock. Let's run that. Hey, where'd that? Nope, that's not it. Okay, give that a big run of the real thing. We kind of just want to see how many are remaining, because there might be an infinite loop in here. So, just run console log RC. That's a constantly spinning number. We love it. It is. Ooh, but it's Okay. They take a lot of time to do that, it appears. Yeah, so, just blindly doing this. Not the most optimal. Okay, I want to see how many there are. Nope, not that there. There. Dot entries. I divide. Switch length. Let's see what I'm really setting up for here. that looks like a lot. Can't see it, of course. Yeah, that's a lot. They're taking a really long time. Um, so I mean, yeah, we have the loop detection as soon as possible. Okay, these are chugging along. Way too slow, right? And I might as well leave it running there. Yeah, who knew? Brute force, not fast enough. Crazy idea. So, my initial thing that worked for everything but was detect when I make a square. And that worked. Okay, here's my revised idea. We make vectors, or we make lines, basically, and we detect if we are crossing a previously made line. So let me grab the map, try and work this out. Mono, please. Okay, so what we have here, we have the grid, and this we make up a bunch of lines. Yeah, let's make that small. Well, I guess let's make it medium. So from our starting position, it's not even from our starting position, it's from a position with no obstacles. So the line we make up is this one, and it does have a direction. The direction is important. And then we make another line. Please snap. Okay, there we go. When we make this direction, this line gets created. And then we come up here, we are on this one, this line gets created. Then we're here, this line gets created. I'm just going to make them all so I can mentally map this. And then, look at here, we got this one way up here gets created. Notice it's not just from where I start to where I end, it's from where I could start to where I could possibly end. It's important because if you ever enter into one of these positions of a line, you should be able to place an obstacle to basically get back on that line. Let me see if I can explain it fully. Yeah, let's drop all these extras and go down to the simplest, the first example, I suppose. So the way the first one works is that we have all these lines in memory somewhere, starts and ends, and we have some other things that does a thing. And then as we are moving along, we detect that current position is on one of those lines. And no, that's basically it. The current position is on one of those lines, and we're not already going in this direction. And okay, the additional logic is that it is a 90-degree to the right to get back on that line. So three conditions of can we place an obstacle to get back into a loop. We're on a line. It is 90 degrees to the right. We can place an obstacle in front of us. Then we do, which would satisfy all of the constraints, including the weird one at the end here, because draw, we would recross this imaginary line. So that's going to be my new approach. Yeah, this is going to take an eternity. I'm going to kill it now. So let's go for solve 2 again. And we have to create these lines in memory. So let's figure out how that would work. Every time we do a rotation, we create a line. And then we just create an initial line at some point. Yeah, so every location or every rotation, create a new line. Line. character thingamabob. Then we create one. Apologies for the initial creation location. Yes, let's see. Const pathing lines. A really great name. Function add pathing line. Makes your current location, does the new line. So what we need to do is where we are currently at. Let's imagine it's right here actually. And where our current direction is, we need to ray trace till we hit the end of something, forward and backward. So const start loc equals loc, const end loc equals loc. Now the trick here is that the starting location, we're going to invert the character to allow us to do traversal on it. Is +2 around the circle, because that gives us a character inversion. +2. There we go. We can use that to get to the true start, and locations just keep moving forward. And then let's make a tiny function. Function lock until end. And here we'll take a location. Let's type this out. Save myself some world. R number, number, R string, lock. There we go. And it's basically, while we're not off the world, just keep moving. I think if it is off in the world, that would be perfectly fine. So I'm just going to steal this conditional healer. There we go. Yeah, it's right here. What are you yelling about? Oh, it's a different thing. Lock 2. Congratulations. Sucks Boogaloo. It's until you hit something. So, all same 3 logics here. And if in front is this, that's the only reason you're ever going to give up, buddy. So, I'll put that down for there. Return. Because the result is you just move location. So, and we have this, and hey, congratulations, start lock. You know, you might as well return the location back for me. Be real pure about it. Love it. Okay, now we have these 2 locations. We need to add it as a pathing line from into, basically. So from start location to end location, and the direction. So pathing lines dot push from R and start to lock C. Well, R C start. Whoa. Lock C to R and lock C. Oh, dang it. And lock C. And then R is, and lock R. Alright, that doesn't change at all. Okay, I think I have this, so if I call it once, pathing line should have 1 in it. Let's drop this weirdness here. Let's make some calls here, I suppose. Pathing lines. Add pathing line. Every time I rotate, add a new pathing line. Let me think. Yeah, it's after the actual rotation, which is after my character assignment. Good. It's a good place to do it. And then let's get rid of these. Save my computer. And get Quokka back on the case. I hear fans kicking up, so let's stop early. Okay, can we at least add one pathing line? It looks like we can't. We do something bad. If in front is a thing, return location. Hey, what happened? The freak happened. I guess I'm gonna need to debug this because I'm not seeing it. Yeah, so let's. I have not actually debugged this in a long time. Hope this still works. We're about to find out. Yeah, this is all very wrong. That installed. Yeah, okay, so we're not debugging that too easily. I can type a JavaScript terminal though. There we go, that'll suffice. Or 6. So let's see if that gets me in here. Come on, let me in. Okay, not letting me in. That's cool. That's okay, we can console log. Move to location, and one of y'all are doing the bad stuff. Who is it? We'll start with you, and then come on, move down. Okay, let's see what we get output here. Tells me little to nothing, so row 6, column 4. Yeah, it tells me little to nothing. Please stop. So let's look at this world, I guess. 0, 1, 2, 3, 4, 5, 6. Column 4. 0, 1, 2, 3, 4. Interesting. 0, 1. No. 1, 2, 3, 4. It's literally my starting position, and I'm going down. Great for you. Why are you not moving then? Yeah, I only stop if I'm hitting a wall, so you should be going down, but you're not. Why? Oh, it would help if I updated my location. Crazy idea, I agree. Who would think? It's always the simple stuff. Hey, look at that, it's running now. And pathing lines, we are getting a pathing line. Great, it's probably going to work now. Let's drop some stuff. I'm seeing some pathing lines that look good to me. We have 11 of them. That seems like a good count, actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Dang, that's an exact count, actually. Okay. So now we have to go through our path and see what happens when we hit the pathing lines. Okay, so this is basically just do it again. Yeah, I'm gonna flip this, drop this, reset location to starting, no, not start, starting location, and it's our rules for what I said way earlier. I am on a pathing line, and its direction is my direction 90 degrees. So the detect if my current position is on a pathing line, which that's I would rather a one lookup, but we can do it out fine. It will suffice. So yeah, you move your life along. You still have to do your navigation. It's really current position I'm looking for, and yeah, current position is what matters. So, where do I do it? I guess I'll do it here. If let's find can join equals pathing lines find, and let's get this thing typed up. It's annoying me. Pathing lines from block 2 to block 2 string. Ta-da! Oh, great, you're being all weird about it. Number, see, number. Okay, good enough. So yeah, find any pathing lines. So it's pl.car equals next car is, I might as well calculate that right here. Really, the character index is what matters, but we'll just do it here. Equals next character, because that's right 90 degrees. So it equals that. And I have to figure out the the fact that I'm doing next character kind of means now I need to make sure that I'm in the range. It's not find, it's a filter. Well, I guess there could be a universe in which there are two pathing lines. Nope, there can't be. There's only ever going to be one. So let's break this up. Characters not equal this. Return false. Now we just have to check that you have a start, you have an end. I need to be in between on this line effectively. How do I do this? It's math. I love math. Favorite thing. Can I get an output here? Yeah, that's somewhat helpful-ish. Really, not that much. Can I get an output of where I currently am? Hey, it's gone pretty well, C Films. Got a little bit of a pathing thing here, but not too bad. I'm slowly tackling away at it. You're doing pretty well yourself. Okay, the location, I am at 6-4 going up. And I am considering joining -1 to 8, which is this one, really. Which is funny because I already have one, so I'm immediately going to stop considering these because I literally see an obstacle in front of it. So if that's bad, false. If cannot place obstacle in +2, false. So basically, I just need to look next row, next column, and be like, hey, if I can't put me an obstacle here, we've given up. Do I still have the code? No, I got rid of the code for placing obstacles. That's all right. So const NNR and NC. Might as well calculate that up here, which means I might as well calculate these up here. So it's this times 2 and this times 2. There we go. So if that contains an obstacle, don't even look. I don't think you physically can look. It doesn't matter which one you're looking at. You're not going to find it. So it needs to be a dot. So if it's not a dot, give up. Also, when I do my world finding, I need to remove this from the world. Well, I'm not actually allowed to place an obstacle there. So keeping this here is actually useful. So, da 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 da. If world NNC equals dot, which means you can be placing obstacles in front of you. Let's see if we consider this stuff. 6 4 1 1 1 1. Interesting. So you're saying you can. Let's get it. Come on. What is happening here? Yeah. What? Okay, which location am I considering? So I'm row 6, column 4. Let's make this a little easier for me. Row 6, column 4. I'm literally at my beginning. I haven't gone anywhere yet. And I'm wanting to place a line right here. There's nothing in front of me. Well, I mean, that doesn't stop you from looking here, so that's okay. 6, column 4. I mean, you're not going to find any. So I guess I need to determine, so the row needs to match and my column needs, so I need to figure out which one is matching, then figure out if my other one is between them. Okay, so if PL dot from dot R equals PL dot 2 dot R, check if C is between from and to C. Else, which I think is going to throw them into the other one, if PL dot C equals PL dot 2 C, else valid PL. Okay, so basically, if location dot C, let's do PL dot from dot C less or equal to location C and location C less than or equal to L dot 2 dot C, and this isn't just an if, it's a straight up return. Same logic down here, but with the R's. Let's see if we got what we're looking for. Pathing lines can join. Okay, 1, 2, 3, 4, 5, 6, 7. Which is what we had from before, and it was just off by 1. Hey, we have something good looking here. Let's return that. Hey, you can add them. Ooh, it's not just lines you can join. It's where I'm placing an obstacle that I can join the line. So it's not just 7, though it happens to be 7. 7's gonna be an undercount. Well, 7 won't be an undercount, the one we're looking at. Why am I seeing the same line up here 4 times? This one up here 3. I'm not liking this. I'm literally seeing this one up here time and time again, yet I only physically get into its possible position once. Hate it. Absolutely hate it. Do not like it. Okay, let's make sure these are correct. This tells me nothing. I think I just need to draw it on the world to really be sure. So for lines, well, let's see what we're outputting. I think we have the negative ones here, don't we? We do. So negative ones and over bounds. So I have to bring it back into bounds and then draw that on the board. Okay, let's look at the first one. 10, 4, 1, 4. 10, 4, 1, 4. Yeah, so it's from way down here to way down here. Direction up. 1, negative 1, 1, 8. 1, negative 1, 1, 8. Yep, that's left to right. Okay, so aside from just the one-offs, I think I can put that back into place. I don't think anything's wrong with these pathing lines, though. Let's look at the last one. 7, negative 1, 7, 7. So 7, negative 1. Up to 7, 7. Yeah, that's the last line. It's from here to here. That's our actual movement. Until we take another right. And we go down. I'm not seeing... So I'm expect to see a line 5, 7. Huh. Yeah, because we have up, right, down, left, up, right, down, left, up, right. Only the first 10 values are logged. Why won't you show me the rest? Of course, the 11th one was the one I was freaking looking for. Okay, so they're all there. My pathing lines are correct. I'm satisfied. Don't need to further debug that. This is a problematic one. I need to only look for somewhere that I can join under the X number of conditions. First condition is that my current position is on a pathing line. My next position, I can place a thing. So it's not next, it's just normal next. That pathing line is a 90 degree to the right, and I'm on it. So let's see if that made it a little better. Okay, it's a lot of them. They're all the same two, though, which doesn't make sense. Unless I'm the same location every time, which I'm not. I'm a variety of different locations. Why you keep hitting these ones, my find must be wrong. So location, come on, get me on the next line, you. Yeah, so 6, 4. So this is the one I would expect to see. Well, actually, 6, 4 right here. 1, 4. So yeah, when I'm on 2, 4, I need to see if I'm on the line. Both of them are being hit. We're not hitting the error. That's good. It's right in here. I've somehow messed it up. If rows are the same, then you have to look at the columns. If columns are the same, then you have to see if you're on the right row. Yeah, the row is, well, one of them can be off by a 1 into the void, undefined land. I don't believe that's an issue, though. Man, if only my debugger was still working, I could step through this freaking thing. I really need to fix that. Come on, new line. Okay, so I'm at 6 4 5 4 4 4 3 4 2 4 1 4, and for all those, look at what I'm seeing. And I am using a dot find. Maybe I need to drop it down to a filter. I would expect to only find one, but my concern is that, look at that, I'm finding like half a dozen. That's illegal. That is literally should not be possible. Should only ever find one. 6 4. How are you finding this one? Oh, I need to be matching this. If that and that. So I need to be matching your row, not just any arbitrary row. Okay, I see it. Eh. I need to figure out how to write that expression then. So I need to be on the row that you're aligned on and within the column. Which means this else might need to drop for false. If location row. So if you're a thing and location row equals row, because they all three need to match basically. Now let's see if we reduce these to ones. Okay, this is looking better. Yes, okay, good. Now we can actually drop back down to the find and it can look normal again. Somewhat normal. I need to break this into separate lines so I can actually see it. Now I should find the 7, 1, 2 on the carrying line. Show me all of them. 1, 2, 3. Interesting. We're supposed to see a few more than that. So there's a rightward line, row 4, column -1 to 6. So row 4, column -1 to 6. Yes, this line here. Okay, I detect that. Oh no, this one's... my idea doesn't work on that line, because that line... dang it. Okay, so maybe not all of our winners. We're just reducing our space. So we'd try it there, we'd fail it there. We'd go into the next one. -1, 6, 8, 6. So -1 to 8, column 6. 6, -1 to 8. It really help if I had these numbers on this one, crying out loud. If I can easily reposition this back now. Oh, great. One of them is sticky. Oh, great. A bunch of them are sticky. Ah, it sucks. Put them back, put them back, put them back. Okay, let me just add characters up top. Oh, make it hard on me. Okay, this will do. So what the heck is that one I just found? -1 to 8, column 6. So column 6, -1 to 8. Yeah, we found this one. That's valid. Okay. And then we never find, okay, we find that one again. Sure, that's great. Find any others though? Actually, we find this one, and then we find this one. We don't find the one I'm looking at. We should have found this one. Okay, we won't find that one actually. We should have found this one. That's the one we should have found really. But we didn't. So let me actually help my eyes for this. So we found this one. We didn't find this one. Why not? Might as well color these ones red that we didn't find and we weren't meant to find. Why didn't we find this one? Man, freaking debugger being down sucks. Okay, let's at least track our locations to where we're failing. So we're going leftward. We are... Let's take this one and shove it away for now. So we're going leftward, row 6, column 5. Hold on, row 6. There we go, column 8, 7, 6, 4. 4. What have you done? Oh, so we don't look at 5. So, okay, but hey, we're on 4, right? We're on row 6, column 4, going left. And then you don't find this one. Let's figure out why. On row 6, column 4. Are that so? Our location is this. I want more information. Equals JSON stringify. I still need a JSON stringify that half. There, okay, so we are being seen. How are you being seen in triplicate? Oh, it's because you're looking at it in triplicate. I do it up here. Okay, we'll see it in single, and then we can see which ones we're considering. So, row 10, column 4, 2, 1. 4, 2, 1. 4, 2, 1. Okay, yeah, we're looking at all 3 verticality ones. That makes sense. So we're looking at 4. That's good. That's the one we wanted to look at. This 10, 4 to 1, 4. It's 10, rows 1. Yep, that's the correct line. Which one do we go down? Well, I guess we just start looking. So where's 10-4 at? Dang, I don't want to look at all of y'all. I need the wrapping bits. Oh, here's 10-4. Okay, good. So apparently we share the same column, which is correct. 4. But my 6 is not good enough for you. Next line. Interesting. False, false. Let me remind myself of the location. Yeah, so we're looking at row, so 6. So PL from row 10 to row 1. 6 is between those two numbers. Have I just done comparisons horribly? So from row 6, well, it's 10, less than or equal to 6. Oh, yeah. That's false. How have I messed this up? I literally wrote this backward. Oh, vertical versus positive versus negative. I see. Oh, this really hurts my head. Yeah, let's make a tiny little helper function. It's gross. It's very gross. Function is between um a well left number number right number number number. So if left, well, let's say small large. If small greater than large, then you'll need to swap around. Small large equals large small. Now I can do my normal comparison, which is this right here. There we go. I think this is the problem I've stumbled upon. Very painful. PL from R, PL to R, location R. Yeah, I'll need to do that for this one. I'm not even going to look the log. I'm just going to hope I've done it good. And I've already messed up by mixing rows and columns. But let's see if that gets us where we want. So yeah, 6, 4. I'm seeing the one I was wanting to see. I'm seeing a lot more too. Okay, this is good. I need just to look at all of them now. So drop the location. See how many we get. We get 1, 2, 3, 4, 5, 6, 7. Okay, this is what I anticipate. Now we need to start placing obstacles in them at the locations. I think it's just the total. Well, it's not just the lines, it's my obstacle positions at these lines. So it is obstacles placed. So const obs right here. So if I can place one, then I place an obstacles. Push. Place it in front of me, which is at NR and C. So R, NR, C, and C. Is that not an array? It's an object. Let's fix that. Boom. And then I think I do some uniqueness. So where's the old part 1 code for that? I'll love it. Let's see if this works. And I think I'm just off by 1. I don't think I need to map this. I can just go straight to this. And yeah, 40 is not equal to 7. You're not wrong. You place a lot more obstacles than I would have liked. Oh, this is only if this. If. Boop. Boop. There we go. That reduces it quite a bit. 8 is not equal to 7. Okay, what the hell? Why'd you place so many obstacles? 2, 3, 4, 5, 6, 7. Interesting. So I think you placed 1 extra because you were about to row 8, column 1 through 10. I'm curious. Yeah, let's look at where you were when you did that. Look with your eyes. Yeah, row 8, column 7, you're going down. row 8, column 7. So you're right here. How are you going down? Oh, okay, you're seeing if you can 90 degree that. But there's already a thing in front of you, so I don't even know why how you're considering. Oh, wait, row 8, column 7, sorry. You're here, you're considering putting something here. It's a valid consideration. Not gonna get you anywhere. Yeah, so I think we have these obstacles. We still need to do that manual call. It's not magically an obstacle position isn't magically being a place where it works. So we do need unique obs. So let's first see if this impacts. 8 to 8. So yeah, we're not reducing any. I think we just let this one go. Drop that 6. Oh, hey, we're actually going back to the number we're supposed to be. That's great. Now, this is where my computer died. So let's drop any console logs. All of my JSON stringifies. Eating my resources alive. Extra math. We don't need next character calculations until we actually need the next character. So let's put that here and here. We need the row offset. We need that. We need to detect that. If something in front of me is a wall, yeah, give up. So yeah, this in front you can move up. Well, not that far up. If in front is a blank, great. Do pathing, yeah, all that stuff happens. Great, we love it. Trying to optimize a little bit here. Yeah, I think I'm ready. Just let it rip. Where'd my 6 go? Oh, I didn't put it there because of the infinite that's about to eat me alive. And there's still something here that I didn't see. So, nom nom nom, my computer. Who's logging? Oh, that's a lot of logging. Doesn't help we're also in the JavaScript debug terminal, so let's kill that. Let's see if that one lets us run. Okay, so now we're doing a lot. Might help me to put log back here. I over stop length. Stop length. Let's see what we're actually dealing with. 1,000. That's a lot more reasonable of a number. Oh boy, it's gonna take somewhat long though. So I've reduced it by 600%. I'm very happy about it. So unfortunately, we do need to do this because 2 of these obstacles don't result in a loop. How have I failed on that? Let's find the 2 that don't and let's track them down basically so that way we can. So else RC. Who are the problematics? 3, 4, and 1, 7. Okay, so 3, well, row 3, column 4. Yeah, so me placing a block here so I can try and join this line. So the only thing that's different from this one is that that is a future line I have not crossed. So if I build up the lines as I traverse through them, and I don't try to do future ones, that might be it. Let's consider 1 7. So row 1, column 7. What? Oh, it's this one here. Yet again, this is a future line that I'm trying to do future stuff on. Okay, we have a pattern. If we don't try and do stuff in the future, will our life be better? Let's try it out. So right now we add pathing lines, and build them all up. If we don't do that, so the alternative is just add the initial pathing line and then add it for every rotation we actually make, do we get less bad obstacles? Well, we don't hit enough apparently. Bummer. Do we get all the pathing lines? I anticipate we do. All 11. How many did we have before? Come on, where'd it go? Okay, we have it there, we have it there. How many pathing lines? 11. Okay, so we do at least end up with the correct amount. So let me try and see which ones I might be preemptively adding on. Yeah, first one we add is there. Second one we add is here. It might be easier just to target the ones that I'm missing. Dang, I just realized 1,000's a big number. Yeah, so we gotta go for this pathing line optimization in real time. Dang it, dang it, dang it. I mean, this code is useless for our purposes. Might as well bring that back. We'll let these two survive. There we go, move the useless breakpoint. Oh, it wants to work now? Thanks. Yeah, 1,000's a big number. Let's not let it run. Stop. Hello? Oh, right, I'm still doing this. Let's pop that. So I should have less than 1,072. Ooh, look at all these loops terminating so quick. If I just took the number 598, return. We start Quokka back up on that. Can we just do that? 598. 598, please, 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 please. Dang it. Answer is too low. Well, hey, that's useful. That is unfortunate, though. Thought I had it. I have a terminal running. I do. It's not too useful, though. Too low, so I'll never hit it on that run. Should have left my 1,000 running. um, so that means there's something. Yeah, so let's put this back into the here. And then, unfortunately, we gotta put this one back in the equation. Very sad to see it happen, but shouldn't have canceled that process from before. I'm trying to think. And you know what? This one might have me a little stumped, actually. At least for how much time I have available for today, or tonight, rather. Hmm. Hmm. Oh. So I'm trying to think of the infinite calculation. Because these are taking a long time. Yeah, I'm getting console log, the ones that don't end in a loop. Alright, that's cool. Maybe my loop detection can be quicker. Yeah, it can be. Because right now I'm just checking I've been in an old position. I can check instead if I am. Location and direction, which is what I have here. So, and that reduction doesn't seem to be as easier. Hmm. You know what? I might not be knocking out part two. Oh, hey, look, some of the terminations are happening. That's nice. Let's see. 6 positions where a new obstruction will cause the guard to get stuck in a loop. Yep. So the logic is you're going across, you cross a line you've crossed before, you add an obstruction, a line you've crossed before, add an obstruction. Let's look at this one. I mean, the thing is, it works in the example, so I'm not sure what I'm not accounting for because it works in the example. Cross a line before, not a position we've been in before, but a vertical line we've been in before. Yeah. You know, I might just call it for this one. So I'm gonna let that one run. I'm gonna go to what I think should have been it and just see if that'll work. So add pathing lines there. Forget about these ones. Go back to here. Trash all of that. As we go somewhere, add a pathing line. So this is post turn before move. Yep, this is exactly what I want it to be. And then the number of obstacles we added, which is the number of pathing lines we've ever crossed before in our life. Let's get rid of the bad one. Well, let's leave it. It's not going to hurt anything. 598, 6. I fix this, I fix that. Do have falses if you're not right 90 degrees. Yep. So I do know my pathing lines are off by 1 in one of their axes or one of their directions. I could tighten that up. Could be what's throwing me off. Yeah, let's do that. So yeah, we're just gonna look here at all the pathing lines. Well, let's look at the 0th one. Let me see. Yeah, it just being off by 1 by this. Not fun. I think the way we do that is in our pathing line, move until the end. They go past the end. So we just want it to go backward 1. Or, yeah, so if it's this, return location. If it's undefined land, also return location. So if this front is this, or and front equal undefined land, return location. Which basically, as you can see by that, drops that. Okay, TypeScript, easy there, easy. Yeah, so they're a little bit more accurate. Still 598. Dang it. I was hoping that off by 1 was causing some issues somewhere. But to know. Thousands, still a big number. Yeah, if there's a dot in front of me, which means I can place an obstacle. It's the only reason you'd ever consider that. Can I place an obstacle? No, the obstacle placing is at the beginning of the universe, so I can't place it on the guard starting position. Do I remove? No, I can't place it at the guard starting position. Is there anything unique about this world I haven't looked at that I might need to do? It's honestly not even that big of a world. It's 100 by 100. Well, it feels 100 by 100. Yeah, it's 130. Close enough. I don't see it. Yeah, so it's gonna go, and I will also go. Do have some schedule tomorrow, so I might not be. Usually, I'd want to, show up a little bit earlier tomorrow to walk through and refactor this and solve it. I will try my best, but I do got life. But that is it for me for this problem. We'll see if this calculation works. If it does, it does. I might try and figure it out, but either way, I'll be back here tomorrow to solve this even further. It's always a pleasure.